So we're going to take a look at two-column flowchart and paragraph proofs, and we're going to use that today. Our main goal then is to switch from one form to the other. So in section 2.6 is probably where you will start with your notes. All right, have you ever told especially a sibling, prove it? I'll bet you have. What do you mean? What do you mean when you say prove it? Ask them how? They have to convince you, right? You want evidence of it? Okay. You want them just to say, because I said so. No, that's not really good. Now, as a parent, speaking as a parent, that's okay. But you probably aren't satisfied with that. So you need some kind of justification. You need them to explain why it is that way, whatever you're discussing, okay? So you want some convincing. That's what a proof is, a convincing argument. Now in geometry, we're going to be using our definitions, our theorems, our postulates in order to prove or justify what's going on. So a little recall or review here. We talked about deductive reasoning yesterday, the process of using logic to draw conclusions from given facts, definitions, and properties. A proof is the argument that you make. Use the logic that we looked at yesterday, definitions, properties, previously proven statements to show a conclusion's true. And what we're trying to prove is typically a theorem, because that's any statement you can prove as true. When we write a proof, it is, as we said, important to justify each logical step with a reason. And I'll show you in the format of your notes in just a second here. Acceptable reasons, and you might think through what we did so far. Remember those algebra ones we did? We supported some of the first lines by just, it was the given equation. So if you're given a fact in a problem, you can use that. And that's what makes one problem different from another, what you're given to start with. Okay, definitions. What are some of the definitions we have done so far? Chapter 1 or 2. Think of things that we've defined. Supplementary angles. Postulate. Complementary angles. Midpoint, I can think of. Angle bisector. What'd you say? Hypothesis. Straight angle. What was today? Definition of congruent angles. Congruent segments. Okay, so there's where your mind has to think. What have we covered? What are some definitions I could use? Postulates, we had like angle addition postulate, segment addition postulate. That would be some computing kind of things we might use. There's probably a few more. Linear pair postulate. Okay, linear pair postulate would be another thing that we could use. So we keep building a few postulates as we go. Properties, names of a few properties. Addition property of equality. Symmetric property of equality or congruence. Reflexive property of equality or congruence. It was both ways. Transitive, right? So there are some properties. And then we had a few theorems yesterday. That linear pair, was that a theorem or postulate here? I think it's a theorem here, and in basic geometry it's postulate. So that's why I get mixed up on which it is, which place. Vertical angle theorem, right angle congruence theorem, so there are some theorems that we've already done. Okay, when we do state the theorems, like the names of it, I'm okay if you use an angle symbol for the word angle and the congruent symbol for the word congruent. Things like that are understandable. If you put P, I don't know what you really mean. Do you mean point P? Do you mean postulate? Do you mean property? You know, so it has to be something that's understandable or clear, okay? All right, so here's how your notes, I think, went. Okay, when we do a proof, we're going to have a hypothesis. That's the beginning information that you are starting with. Usually a proof at a problem that you're doing will have a diagram and then some other written out information. In that list that I just went through, you can have, in addition to the given, you can have definitions, postulates, properties, theorems. Those are acceptable reasons. what we're trying to do is get to the conclusion, the statement that we're supposed to be proving. So the problem will really tell you what to begin with and where to get to, and you're supposed to come up with the in-between. And that in-between can look different ways. There's what's called a two-column proof and a flowchart proof and two-column flowchart and paragraph proof. We'll take a look at each one. All right, and I've said that a few times here. All right, this is what a two-column proof would look like. A two-column proof, you are going to list the steps of the proof in the left column and the matching reason in the right. That's how we set up those algebra ones that we did just a couple days ago. We will title each side, this is statements. These are the reasons. And to make sure that we're matching them up correctly, we'll say, okay, line 1 statement, here's line 1's reason. Line 2 statement, here's line 2's reason. Line 3, and so on, however far it needs to go. So you're numbering them so that you know how they match up. That's what a two-column proof is going to look like. So you really kind of did that when you were doing the solving ones and giving the reasons. All right, let's actually look at and write down a complete example of a two-column proof. You got room there for notes? Yeah, I think you should write it down in your notes. You'll want to look at these again. Okay, so notice you are given some information, and on this one you're given that B is the midpoint of segment AC, and also that segment AB is congruent to segment EF. So that's all the hypothesis stuff that you can use. Plus there's a diagram that you can use. That diagram, it looks like B is between A and C. EF is a completely different segment. Okay, what are we trying to come up with? We're trying to prove or convince someone that segment BC and segment EF are congruent. Now, before I show it to you, let's do some thinking. Can you think through it? Okay, what's it mean if B is the midpoint of segment AC? Tristan?
It's equal length from segment AB and then segment BC are congruent.
Okay, segment BA is congruent to segment BC.
And then
Do you know what you base that on?
it's the midpoint phase.
Okay, so let me kind of fill you in. What you were thinking of is, what is a midpoint? What's the definition of what a midpoint is?
Middle.
Midpoint definition said a midpoint was a point that divided a segment into two congruent segments. So you told me the two congruent segments, so that's what you were using, definition of a midpoint. Okay, were you going on further?
Yeah, and then the proof, well, AB is congruent to EF, which
Okay,
would make BC.
Right, you were given, hang on a second, you were given this also. Okay, so if AB's already got that mark, EF's gonna have it. And what were you finishing?
And then since AB is congruent to BC, BC is going to be congruent to EF.
What's that sound like? He said if AB is congruent to BC, and then BC is congruent to EF, we can get AB congruent to EF? What's that seem like? Transitive property of congruence. Okay, good job. Here's what it looks like. First idea was B is the midpoint of segment AC. That was given. Then Tristan used the definition of a midpoint, came up with those segments congruent. Now this one threw in a symmetric property. We'll have to see why that needed to be in there. What symmetric property allow you to do? switch it around. So see line 2 was switched around to make line 3. We'll see why once we get down another line or so. Okay, then there was another given thing, segment AB was congruent to segment EF. And finally, we said the transitive property, it used lines 3 and 4. We ended up with BC equals segment EF. That's an example of a two-column proof. Why was that symmetric necessary? If we didn't have line 3 in there, we just had this statement, line 2 and 4, could we do the transitive property? Is the right-hand side of one the same as the left-hand side of the other? If you look at that, you might notice no. The left side is the same both times. So that symmetric was in there to flip the congruence around to have the AB on the right side so that you can connect with the transitive property. If we had just written line 2 in the other order originally, because we made that one up, if we had written it like line 3 originally, we wouldn't need the symmetric property. So sometimes you do a proof and then you think, oh, I could have made that a little bit better if I would have done it this way. So you change it and perfect it a little bit more. But I wanted to throw in the symmetric, so that's why it's in there. So how do we know we're done? We got to exactly what it said to prove. In the same order, identical. Thumbs up or down, that one makes sense? You see how the two columns, the statement and the reason match together? I would say there's going to be a variety of different kinds. So they're not all going to look just like this. Are they going to have 5 lines? No. Some would have less, some would have more. It just depends upon the problem. And that's where geometry can't be just like algebra. You're not going to have, 5 that look just like this. Everything's a little bit different. Okay, but that's a 2-column proof. Another style of proof is called a flowchart proof. So I think you'll have to flip a few pages. Is it in the 2.7 section? Okay, flowchart proof. This is more of an informal look to it. It uses ovals for the statements, and arrows show the flow of the ideas. Instead of numbering 1, 2, 3, 4, 5, we use arrows to show this idea leads to this one, which leads to that one, which leads to that one. So you have to kind of see how the ideas go in sequence to draw your arrows. The justification or the reason will still be there, and it's just going to be right below the oval. So here is a different proof, and here's what the flowchart proof would look like. So this isn't the very same one that you had before. This is a different one. So let's go back to what you're given and what you're going to prove. I'll show the flowchart there in a little bit again. We're given that RS is the same length as UV, and we're given that ST is the same length as TU. So it's given in the words. As you work the problem, especially, you want to put the tick marks on the diagram. Now before I show you the solution, I'll think through it a little bit. Can you prove to me that RT is congruent to TV? Can you get RT to have the same length as TV? These two are the same, and these two are the same. Will RT's total and TV's total be the same? Yeah. We need to add some things together, right? We need to add RS and ST together to get what RT is. We need to add UV and TU together to get the whole thing. If I wrote this statement, RS plus ST equals RT, do you recognize what we've studied that supports that? Segment addition postulate. We're going to have that in this proof in order to add those together to get the whole thing. Alright, so here again is what the proof looks like. Notice how the arrows connected. So I'll probably start at the left over there. RS equals UV, ST equals TU. That was all given. We could have put that in two separate ovals since it was the same reason and it was all there at one time. We just put it all together. Okay, that says that idea leads to the addition property of equality, not the segment addition postulate yet, but you're just adding those two together. So the left sides were RS plus ST, and the right sides were UV plus TU. Now, before I can go to the very next one, we have to bring in another idea. So this is that segment addition postulate that we took a little look at. RS plus ST is going to be equal to RT. TU plus UV is equal to TV. And notice there's two arrows now that come together. That one and that one, those ideas together by substitution property of equality, it's kind of abbreviated here, to come up with RT equals TV. We'll come back and look at that one when you're done writing. Then the last idea is, that means that segment RT is congruent to segment TV, definition of congruent segments. Now look at that substitution. Substitution means you can take something out and put another something in its place that it's equal to. So that's why there's more than one arrow leading into the substitution. You need multiple ideas. So if I can help you, if I use this as my base statement, what's RS plus ST equal to? RT. We know that because the segment addition postulate says it right there. So that can be replaced with RT. TU plus UV is the same as TV. So that can be replaced with TV. So when you do the replacing, you get what the substitution oval says. Why did you have to change from this to the end thing? Look what you're trying to prove. You were trying to prove congruent. You have to get to the congruent. So we had to switch from equal measures to congruences to really prove what we were doing. All right, do you understand statement, reason? Statement, reason. Where the information is? Now, if this were a two-column proof, how would it probably be numbered? I would say this would probably be statement 1, reason 1. Statement 2, reason 2. Statement 3, reason 3. Statement 4, reason 4. Statement 5, reason 5. Okay, that's a flowchart. The last type is a paragraph proof. Didn't quite get that? How close were you? Almost done? Okay, let me go back one more. Just about. They should all be in the textbook also. Got it? Okay. All right, here's the paragraph proof information. It's a style of proof that presents the statements of the proof and their matching reason as sentences. So they're going to connect the statement and the reason with a linking word like because. This because of the definition of congruent segments. Instead of because it would get boring if you use that all the time. You just kind of switch up and do some other connecting words. It's going to look less formal than a two-column, but it still has all the statements and reasons just written in sentences. It's kind of small there, I didn't get that enlarged. But here's going to be a paragraph proof. Kind of a short little paragraph, but notice how it's written in sentences. Is that big enough for you to see okay? Mm-hmm. Yeah, let's look at the original problem. We're given that angles 1 and 2 add to be the same as the measure of angle 4. And we're going to try and prove that the measure of angle 3 plus 1 plus 2 is going to equal 180 degrees. the information given. We can look at the diagram and see how we can do this. Okay, so here's the solution. It is given that measure of angle 1 plus measure of angle 2 equals measure of angle 4. What reason is mentioned in that first sentence? Not in the first sentence. What's the reason that's mentioned there? Given. Yep. It is given. That's the reason. Here's the statement. Measure of 1 plus 2 equals 4. And then it goes on to say angle 3 and angle 4 are supplementary using the linear pair theorem. That's where the linear pair theorem is the reason. Angle 3 and angle 4 are supplementary is the statement that's being supported. So, measure of angle 3 plus measure of angle 4 equals 180 according to the definition of supplementary angles. There's the reason. And by the substitution property, there's the reason. Measure of angle 3 plus measure of angle 1 plus measure of angle 2 equals 180 degrees. When you're going through, do you recognize statement, reason, reason? If you switch this into a 2-column, what goes line 1 statement, line 1 reason, line 2 statement, line 2 reason. I think while that one's showing up there in summer finishing notes, let's take that one and put it into another form. Let's take that same one and let's put it into a 2-column. Statement, reason. This is the type of thing I'll ask you to do on problems on your homework. What's the first statement? What's the first reason? John?
The measure of angle 1 plus the measure of angle 2 equals the measure of angle 4.
Reason?
It's given.
Where do you get that first sentence? Line 2, statement is what? Jaden. Can't quite hear it. Second one. Yep. I think you skipped a sentence. Back up a sentence. John did this one. It is given that. Okay, so now, next thing says angle 3. Our supplementary. Reason. Linear pair theorem. Okay, sentence 2, done. Okay, line 3, statement. Page. Reason. Line 3, done. Line 4, Michael.
Measure of angle 3 plus the measure of angle 1 plus the measure of angle 2 equals 180.
Measure of angle 3 plus measure of angle 1 equals, or plus measure of angle 2 equals 180. And that was substitution. There's it in 2-column form. We just switched from one form to another. Question about the 2-column form. for today, that's what's going on. Okay. Monday, we're gonna try and like fill in parts of it. It'll have some blanks in it. It won't be completely blank, but there will be some missing parts. Okay, so let's take this same one, and what other form do we need? Flow chart. Okay, what's your first oval gonna be? What goes inside it? Let me see if I can get a few more people here. Bring it up. First oval.
Measure of angle 1 plus measure of angle 2 equals measure of angle 3.
Reason.
It's given.
Okay, now, you could either get that from the first sentence, or she was looking over here, coming up with the first question, okay? Now, in a flow chart proof, we need to figure out line 2, whether it's here or there. Do I need to connect this one to line 2? Okay, so let's see. Do you have to know this to say this? Angle 3 and 4 are supplementary. Does that come from knowing that? No? Well, what's the linear pair theorem's hypothesis? What do we need to use this theorem? Okay, so does this tell me two angles form a linear pair? No, so we don't need this. How do we know two angles form a linear pair? Have to look at the picture in this one. You have to look at that picture. So my point is, you don't connect this one to our next one. So I'm gonna go to a new space here. Okay, so my next one's gonna say angle 3 and angle 4 are supplementary. Linear pair theorem. So those are kind of two separate ideas. Okay, third line, I'm gonna look over here. Definition of supplementary angles. So if two add up to 180, they're called supplements. Or if they're called supplements, they add up to 180. Which angles are we talking about? 3 and 4. Kind of need to know this, don't you? To then say that they add up to 180. So this one is connected to the fact that measure of angle 3 plus measure of angle 4 equals 180 degrees. Definition of supplementary angles. Last line, by substitution property. Okay, what has to be put together? I know I need at least two things put together to do substitution. How do I get this out of that? What do we want to end up with? We want the measure of angle 3 plus measure of angle 1 plus measure of angle 2 equals 180 degrees. Can we get that out of these two things? Raise your hand if you're seeing it. You think you can see it? We only got about 3. Megan, what are you seeing? This one? Okay, what are you taking out of this one? You're not taking out the 180, it's still there. The 3 is still there. You're taking out measure of angle 4. What can you replace it by? What's it equal to? Measure of angle, did I write it down wrong? I did, that's why we're having trouble. I wrote it down wrong. Nobody told me that? Okay, angle 4 is 1 and 2 added together. So if I took out measure of angle 4 and put measure of 1 plus 2 in its place, would that create this equation? My mistake there. Okay, so that can be created from this one and this one by using substitution property. Equality. Gotta write it down right or it doesn't work. Try not to have your arrows, or don't have your arrows cross over. So if you find that you're having to cross paths, like you put this over here and it's kind of turning into a mess, erase it and put it somewhere different, okay? Typically go down or go to the right. as you do that. Molly?
I need to go.
Yes. Did you get the assignment yet?
No.
It's a worksheet, so I can come out to you. Okay, let's do another switching and then, let's see. Did you get that proof styles? Proof styles? All right, can you give me a thumbs up or down? Did you understand switching from one form to the other? Thumbs up or down? You doing pretty good on that? Okay, I'm kind of debating if we should do another example or just get to your quiz.
Just quiz.
Are putting it into that form? Okay, we can do one of those and then call it quits. Okay, so there's 2-column flow chart and paragraph proof. Okay, let's do another one where we put it into flow chart. This probably is the hardest one because you have to see what's connected. So let me find another proof here. That's the one that we just did. That one, yeah, oh, that's flow chart already. That's flow chart already. Okay, this one is in a 2-column, let's put it in flow chart. Okay, so you gotta look at what's given, what you're trying to prove. Think what they're doing here. Line 1. Dalton, what do you think we'd start with? Or what? What's that symbol mean? Help him out. Congruent. The other C word. Angle 1, congruent to angle 4. What's the reason? Okay, now, next line says vertical angle theorem. So do we need angle 1 and 4 to do the vertical angle theorem? No. So that tells me new idea. Don't connect it with arrows. Okay, so new idea. Angle 2 congruent to angle 1. You want to do it? Let's separate them. Let's see what happens if we, instead of putting them together, we separate. It might be easier to do the rest of it separate. So this was vertical angle theorem. This was also vertical angle theorem. I just pulled it apart. Okay, line 3. Angle 2 congruent to 4. Transitive property. 2 congruent to 4. What can be put together with transitive to get 2 congruent to 4? Which of these 3 have the connection so that angle 2 is listed first, angle 4 is at the end, and the in-between connection drops out? They know which ones. Which ones? Write it. Which ones? The first and the second one. Right. If you think about this one first, we've got angle 2 congruent to angle 1, then the same angle 1 is congruent to angle 4. So putting that first and then this, we can come up with angle 2 is congruent to angle 4 by the transitive property of congruence. Arrow, arrow. Those ideas lead to that. Last line. Angle 2 is congruent to angle 3 by transitive property of congruence. Which ovals do I need to connect? This one and this one will do a transitive?
Yeah.
Which angle, okay, transitive has to have a repeater thing. These are all different. We really can't connect those with transitive. You need an angle that's the same to do the transitive. Abby? See the angle 4 that's repeated? Okay, so we can get the first angle would be listed as angle 2. The last angle listed would be angle 3. So this one and this one come together to make angle 2 congruent to angle 3, and then a transitive property of congruence. And that was the end. So there's another flow chart, for example. All right, we probably better end there with our examples. The assignment is on a worksheet, because I got some different kinds of proofs written out and asking you to put it in a different form. There are a few other types of questions in here. But that's our goal for today. On Monday, we'll try and fill in some of the missing parts. Are you working on that worksheet, the terms and concepts that I gave a few days ago? Did you forget about it?
Who's that due?
Due on Tuesday. All right, so that worksheet packet is your assignment, and a lot of it is changing from one form to another form, seeing if you can follow the thinking process. Need one more? Okay, then put things away and we'll do our quiz. As soon as you're done with your quiz, you can get out your assignment and work on it.